properties అంటే ఏం చెప్పొచ్చు చెప్పండి అన్న. The properties which shows a regular gradation in groups and periods, how it is going to change. That only we are saying, no?
Yes, sir.
This is what we can say about the periodic properties. So in the periodic properties, what we can have, what are we are having periodic properties like so periodic properties, what we are having generally atomic size, atomic radius, these all things are there, right? Now first we need to discuss about the atomic radius and how the atomic radius is going to change. Okay, with change in atomic number, how it is going to change in periods and groups, that we need to see right now. Okay, let's start. Screen rare Chrome tab entire screen. You can see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
First one is what we can say atomic radius, Nana. Atomic radius. How you can define atomic radius? Tell me how we can define atomic radius. It is the distance between nucleus to
or valence cell.
valence shell. What happened?
Sir, nothing, sir.
Uh,
Ah,
it is the distance between nucleus to valence shell. Okay, that we can say that atomic radius, right? For example, so this is like a nucleus which I am indicating with the dot, and these are like so this is from here to here the valence distance is there, no? This we can say as a atomic radius. Whereas in case of ions, we call it as a ionic radius. Okay, no. What we can say in case of ions, and in case of ions, the distance is called ionic radius. Okay, ionic radius. Now let me compare. So ions means what? It can be cation or it can be anion, right? Because we have anion and cation also, no? So how we are going to compare the ionic radiation and how it is going to go that way. So before going to that, let me go with how this atomic radius changes in group and in periods. Let me take in group. In group. Can anyone tell me how atomic radius can changes? In a group from
Increase.
from top to bottom, with increase in atomic number, atomic size also increases. Okay, atomic size also increases. Okay, right? So how we can say that? For example, let me take a first
So the
group
number
element.
of electrons increases, so shells will also increase.
Yes, because
Sir, anion means plus, sir.
I will tell you, what is anion, what is cation. Because of increase in number of cells. Number of cells. Okay. For example, let me take. I'm taking. We have lithium, sodium, potassium, rubidium. These all belongs to same group, right? Whereas if I'm writing the lithium valence configuration is 2s1. So sodium valence electronic configuration I'm writing. Okay, na 3s1. Okay, let me write. You people can number of atoms only, no? Let me write complete only. What is lithium configuration? 1s2 2s1, right? Whereas here 1s2
So 2
2s2
has 2,
2p6
has 2 physics 3 has 1.
3s1, and here 1s2 2s2 2p6 3s2 3p6 4s1. And in rubidium, what is atomic number? Lithium 3, this is 11, this is 19, and this is how much, Nana? 37.
7,
Tell me.
37, sir. I'm saying that.
Okay, so configuration will be 1s2 2s2 2p6 3s2 3p6 4s2 3d10. What we can next one?
Sir,
What
5 s
happened?
2, sir. 5 s 2.
4p6 5s2, no?
Yes, sir. 5 s 1, sir.
I'm sorry, 5s1, no? Now if you are observing, so what is the valence cell here? There are two cells here, and here we have third cell is the highest, and this is fourth cell, and this is fifth cell. So as number of cells increases, obviously size will also increases. Okay, na? Yes or no?
Yes, sir.
Now coming into periods.
Sir, once
In
could you go to the
periods,
previous slide?
Okay, sir.
in periods ఏం చెప్తా చూడండి జనరల్గా in periods from left to right, with increase in atomic number, with increase in atomic number, what will happen? Atomic size decreases due to the new electrons added into the same cell and by and with increase in atomic number, Number of protons also increases. Number of protons means nucleus power or nucleus charge increases. So that size decreases. For example,
Sir, I have a doubt.
tell me now.
So in the second line, atomic size increases or decreases, sir?
Atomic size decreases now.
So you write it decreases, sir.
Decrease when I'm saying that now.
Yes, sir. Yes, sir.
In group increases, in periods decreases na.
Yes, sir. Yes, sir. Okay, sir.
With increase in atomic number, atomic size decreases due to number of electrons added to the same cell, and with increase in atomic number, the number of protons increased, so size decreases. Correctly written, no?
Yes, sir.
Let,
Yes, sir.
let me take a second period I'm taking, that is lithium, beryllium,
Sir, barium, boron, carbon.
nitrogen. Let me take till nitrogen. Okay, nitrogen, oxygen, fluorine also we are having, fluorine and neon also. Nitrogen, fluorine, neon. Let me take like this. Okay, so what is the lithium configuration? 1
1
s
s 2
to
2 s 1.
beryllium,
7 s 2 2 s 2.
and here what will happen? 1 s to 2 s
2
to
s 2
2p.
2
Now see,
p1.
the new electron is added to into the same cell, right?
Yes, sir.
And nitrogen 2p2.
So 2p3.
Nitrogen 2p3 over it will be, no? It will be 1 s to 2 s to
So 2p5.
nitrogen in between oxygen also it will be there, no?
Yes, sir. So 2p5.
2p5.
2p6, sir.
Let me write it clearly. Now see, as it is electricity, lithium also having same number of electrons only. Okay, same cell only. But what happened here? We are having only 3 protons, and here we will have 4 protons, and here we will have 5 protons, and here it will have 6 protons. Likewise, we are having, as we are number of proton increases, so being electrons are negative charge, so which are strongly attracted by protons, right? So that what will happen? So straightly it will come towards, straightly, not more, straightly it will come towards the uh, nucleus. Okay, that's why size is going to get decreases. For example, if I'm taking uh, if I'm writing no in terms of picometers, so lithium will have nearly 152 picometers, whereas beryllium will have 111 picometers, and boron is going to have 88. See how much it is gradually decreasing. 77, nitrogen 70 picometer, oxygen okay, slightly it will become 74. See, as you are coming that one, it will decreasing gradually. It is decreasing, no? So it is 74. 1 second. 70. Okay. Now what we can say as gradual increases, na, as coming into neon, it will have 160. I will tell you why in case of neon increases. Okay. Now see, till initially decreasing very fastly. After that, it is decreasing very small values. It is decreasing, no? Yes or no?
Yes, sir.
This is why we can say about the in periods how it is going to take. Whereas in case of inert gases, whereas in case of inert gases, uh, due to increased electrons, because 10 electrons are there, no? Increased electrons causes interelectronic repulsions. Okay, due to this size increases.
So can you go to the previous page once?
Size increases. Okay, these values are not required, just I am writing only for your knowing how it
Sir?
is. Tell me, Nana.
Sir, here in the writing, you wrote no protons or number of protons, sir.
Number of protons, number of protons. It is number of.
So we can say that the shells will be fixed, but the nucleus will increase, right?
Come again.
So we can say that the shells will be at the same position, but the nucleus will increase size.
Nuclear charge will increases as the nuclear charge increasing. So what will happen? It will pull the electron, last electron towards
Yes, sir.
itself. No.
So the shells get closer towards it.
Yes, less slightly. Okay, already picometer is very less unit. No.
Yes, sir.
1 picometer means what? 1 to the power 10 to the power of minus 12 meters, and it is coming lightly nearly.
Okay, sir.
Okay.
Okay, sir.
Next one. So already we have discussed, no? So ionic radii and ionic radii comparison. Ionic radii and comparison. So already I told you, no, ionic radii means what? What is ionic radii?
Sir, ion.
Means what? In ion, okay?
Yes, sir. In ions, the distance between the electrons and the nucleus.
Yes. Nucleus to valence electron.
Yes, sir.
Okay. Should I write or okay? Now generally, let me take, if I'm taking an arbitrary x an element I'm taking. Okay, x an element I'm taking, which can form by losing electron, it will form cation and it will form x minus, that is anion by gaining electrons. Mm. Tell me, which is going to have?
Sir, X plus.
Tell me, Nana, which one is going to have highest? X.
Sir, x plus will have less and x minus will have higher, sir.
Why?
Sir, because X plus have more protons than electrons, sir. So the pulling capacity will be greater.
and X minus have more electrons than proton,
830.
so the pulling capacity will be lesser.
Sir, what did you ask, sir?
One second, student. 1 second. ఏంటి బాధ Sorry,
Sir.
students. Actually, I'm asking. So, hello.
Yes, sir.
Sir, once
I'm
could you move
asking.
the previous slide?
I'm asking. 1 second, wait. I'm asking among x plus and x minus, which is having greater size and which is having least size, and
So
why?
X minus, sir.
Sir, X minus will have greater size, sir.
Because the inter-electron repulsions will be less as there'll be more electrons.
Yes.
Sir, and X plus means one more proton is there which will increase the force of attraction, sir. Minus means it will be the same.
Yes. Very good. See, it means mm, x is what we can say.
Per
For
atom.
example, let me take x is having some any number of electrons. Let x is having, let it is 10 protons and 10 electrons. And x plus how many protons it will be there? 10 protons only,
9 electrons.
9 electrons. And here it will have 10 protons, 11 electrons. So as I told you earlier, as the number of electrons increases, interelectronic propulsion increases. So as the interelectronic propulsion increases, obviously size will also increases, right? So because of this, x minus will have greater size as compared to x, and x plus will have least size as compared to x. That means,
So like the protons will dominate electrons in the X plus, sir.
yes. Okay. So the size order will be what we can say, x minus is highest, then x, then x.
Or if electrons add, the atomic size will decrease, sir.
Huh?
If new electrons will be adding, the atomic size will be decreasing, sir.
Array, it will increases, no. By adding of electron means what? It will form anion, right?
Yes, sir.
In anion,
Sir,
what did I say?
Size will increase.
Hmm. Anion, how it will form?
adding of electron.
That only, no?
Sir, I have one doubt, sir,
Hmm.
from the previous one, sir.
Uh,
Sir, if we go from left to right in period, then it will atomic radar will decrease, no, sir.
yes.
Sir, but inert gases atomic size increases like any groups, sir, like all the groups only, or is there any special case?
No, no, all groups.
Okay, sir. You wrote specially means I thought something other
No,
cases
no,
there,
no,
sir.
no, no, no. Next.
That's it.
Done?
Yes, sir.
Hmm. Next one is uh, so size comparison. Okay. Atomic size comparison in isoelectronic species. Hmm. What is isoelectronic species?
Sir, same number of electrons, sir.
Yes. Isoelectronic species are Are the molecules or species which have same number of electrons? So in this one, how size will changes? We need to cover. Okay. Listening students. Let
Yes,
me
sir.
take this. Hmm. If I'm taking in n minus 3, how many number of electrons are there? N minus 3 means what? Nitrogen 7 electrons, which is gaining
Yes,
3
sir.
electrons. Hana?
Yes.
O minus 2 means what? Oxygen having initial 8 electrons. By
10
gaining 2
electrons.
electrons, it will become 10 electrons. F minus also, how many electrons will be there? 10. And neon, 10. Sodium means what? Generally 11 electrons are there. Plus means 1 electron lost. So that it will also have 10. Magnesium is 12 minus 2. Everybody know, no? How we am writing 10 electrons? Okay. So anion means we need
Yes,
to
sir.
add to the its original atomic number or atomic number or electrons. Cations we need to subtract the charge. These are all isoelectronic spaces. Now tell me in size which is having highest.
Sir, nitrogen minus 3.
Why?
Sir,
Because it has more number of
electrons are there,
electrons
than
adding, sir.
protons, and it
Uh,
electronic repulsions.
yes. So among anions we can write which we can say.
Most electrons anion.
Yes. So that means we can have n minus 3 is highest. Next.
Oxygen minus increasing, sir, like that one decreasing.
Yes. Now what we can say here? Highest will be n minus 3, then O minus 2. Very good. Then F minus. After that, which one we will write?
Yeah, sir.
Because we know anion, after that neutral atom, then among cations, which is having highest least size?
Sodium
Sir,
least, sir.
aluminum, sir.
Aluminum plus 3.
Aluminum. Why? Because the number
Because
of
adding
protons.
of protons will decrease the atomic size.
Electrons are less. Protons are
Very.
not added.
Okay. Okay. Electrons
Sir, the
only we can
adding
add or
of
remove. We can't add or remove protons. Remember all of you. Protons and neutrons cannot be added, cannot be removed. Only electrons only can be added or can be removed.
Sir, neutrons can't be removed, sir.
No, how you can write? Site in nucleus it will present, no?
Sir, isotopes aren't made, sir.
Huh?
Some isotopes are made, na, sir.
Isotopes means what?
Number of neutrons differ, na, sir.
Isotopes, nana, isotopes.
Same atomic mass, but neutrons differ, na, sir.
That is isotones, no? Isotone it is, not isotope.
Okay.
Isotope means same atomic mass. Okay? That means what we can write? What we can write here? In isoelectronic spaces, can I write like this? With increase in atomic number, atomic number size decreases. Can I write like this for your remembrance?
Yes, sir.
Yes. This is only isoelectronic species and its comparison, nothing else. Have you understood how atomic size and how it is going to change? Okay, na?
Sir, 1 minute. Done, sir.
Okay.
Yes, sir.
Let's come to next. This is first atomic property, and second atomic property is okay, ionization potential or ionization energy.
Try P, sir.
Yes.
The radius types are not needed, sir. Now metallic radius.
Not
those
not
are-
required. Not required.
So we are not going to discuss ionic radius in groups and periods.
We have discussed now.
The ionic radius.
Ionic radius, it depends on the ion charge only we can define, no?
Okay, sir.
For
Yes.
example, in group, if I'm taking all are having mono valence ion only, so obviously it will increases only.
Yes, sir.
Mm. Okay, next one, ionization energy.
Potential, na, sir.
You can say energy or energy ionization potential also. That which we can represent with ionization energy means IE. Or ionization potential. That is IP. Mm. Now see, generally what is ionization potential? Okay. Ionization potential means or ionization energy means, okay. Remember very clearly how we can define and what we are going to get. Generally, ionization energy means the minimum amount of energy required to remove the minimum amount of energy required to remove uh, the most loosely bounded electron from an isolated gaseous atom to form cation is called ionization energy or IP. Okay, that means what we can say, for example, okay, that example, first example, let me one element is there, from there I am removing one electron. Okay, for that, to remove that electron, how much energy you need, that only we are
Center
saying
of
that
atom type
ionization energy or
like
ionization
sir.
potential. Let me take
Sir, what is
uh,
isolated gaseous atom, sir?
so that means it should be not in combined form. it should be individual atomic form, it should be, and it should be gaseous state, it should be, because any atom can be converted into solid,
Compulsory.
liquid, gas, no?
Yes.
Okay.
Is it compulsory, sir?
It's compulsory that atom must be in gaseous state only.
Okay.
Okay.
Yes.
Mm. Mm. Next way. For example, an element metal M is there. Metal or atom, whichever it is, it should be in definitely in gaseous state. When we are removing electron, okay, that it will form M plus, and it will give one electron. In this process, delta H, we are saying that IP. This value will be positive or negative value. This value, whatever the value we are getting, no, that will be positive value or negative value. Please tell me.
Which one, sir?
Here we will get no delta H is known as some value we are going to get, no.
Yes,
That
sir.
only we are saying that IP, no.
Sir,
Sir, we will
uh,
get negative, sir.
Negative.
sir,
Yes,
positive,
sir.
sir. Positive.
Positive, no. We are saying that no, no energy required.
We are giving it heat, sir.
So when energy is giving, that means what we can say delta H is positive.
Negative.
So if we are removing one electron, that is we can say IP1. Okay.
So also we are giving negative energy to a positive atom, right?
Negative energy, how it can be? Negative energy will be there.
No, sir.
Sir,
So
then
energy,
for removing
if you are
electron,
giving to
we
any
energy.
atom, okay, that we can say as a positive. If energy is released or energy is given out by the atom, that means we can say the heat released will be negative value, we can say. Okay, like exothermic endothermic reaction we will say, no. You might know what is endothermic, what is exothermic. In the same way it is also.
Yes, sir.
Okay.
Okay, sir.
If we are removing one electron, that we can say IP1. And if I'm taking from M plus, this is also gaseous only. If I'm removing one more electron,
Sir, MV is manganese.
metal, a simple element,
Okay.
it will form M dipositive or M2 plus by losing electron. In this process, the heat released, which is called as a IP2, because from metal only, some element M only, we are removing one more electron. Na? That means what
Yes,
we
sir.
can say in first case, we can say simply from metal M2, we removed one electron. Whereas in second case, if I'm taking this M only, metal or any element, we are removing two electrons. Instead of taking the two electrons, how we are getting from the value we are removing. Understood what I'm trying to say? If I'm trying to remove one more electron, so element remains same only, no?
Yes, sir.
So in this case, the energy released is known as IP3. Now tell me, among IP1 or IP2 or IP3, which is having highest energy value?
Sir, IP3, sir.
Can you please tell me why?
Sir, because sir, when we remove an electron, sir, the metal becomes unipositive ion, and in this ion, the forces of attraction between nucleus and valency shell increases. So more amount of energy is required to we require more energy to remove that electron, sir.
Yes.
Sir, and the proton will be attracting the electron no matter what, sir. And there are more number of protons than electrons, then it will be harder, sir. It will be
More,
double, triple.
yes, more
Like
amount of energy required. Okay. Okay. Tomorrow we will discuss why IP1, IP2. You said, both of you said it correctly only. So tomorrow we will write it on that. Okay, and we will continue.
sir.
Okay. Na?
Sir?
Understood
Sir,
what I'm
when
trying
this
to?
yes, sir. Sir, when this topic was over for 8th class, we wrote the notes, na sir. Will you tell any new information or no need to write again, sir?
No need. Generally, to whom we have completed, no? It's not
Yes, sir.
necessary. It
Okay,
is
sir.
not getting downloaded only. Why? Now, 1 second. Let me check my downloads whether it is downloaded or not. I don't know why it is not downloading. Acha. What is the date today?
Feb 16, sir.
Okay, okay. It's already downloaded now. Okay. Bye, students. Good night.
Thank you, sir. Bye, sir. Good night.